That's what I'm trying to find right now. Sorry, hold on, Lori. I'm looking. Let's see. I should have been prepared before, and I wasn't.
It's okay.
Normal distribution applet? Oh my gosh.
Hold on. Yeah, something like that. I need to put it just on my computer so that I
do too.
Automatically have it on there.
Normal probability applet.
Okay. Yep, that's it. All right.
I think probably we should just go into the quiz, and then whatever we have, we can look back at the homework.
Okay. Sounds good.
See what we do.
All right. Group 7 or number 7, right? I'm doing this group meeting number 7. I'm right.
Yeah.
Okay. Can you tell I'm paranoid now? All right.
It's all right. We're all in it together.
Okay.
Okay.
Oh my gosh, it's recording me or something.
What's recording you? All right. To the right of B. Okay, so on this one, what does it say here?
Okay.
The combined area of the standard normal curve that is to the right of Z. Round your answer. Okay, use the normally probably to find the combined area under the standard normal curve. So do we highlight the underneath, like the curve, or do we do to the right of Z? See, this is where I'm starting to get confused.
Well, it says it. It's to the right of Z and the left of Z.
Okay.
So it's the middle.
But we highlight the blue used to find the combined area under the standard normal curve. Okay. All right. Oh, let's see. I didn't change that. And did we lose Lori?
I don't know. Yeah.
Okay. Let me see.
Got her.
Okay. Hi, Lori.
I have no clue what happened.
Yeah, me either. All of a sudden you were gone.
Yeah, mine froze. So.
Oh, okay.
Okay, so I'm going into the group meeting.
Pages. Hey, Saturday. We are taking you shopping.
Okay. Okay, so Lori, on this first question, when you get there, let me know and I'll ask you it because I'm confused.
Okay, I'm looking at it right now. Here's the normal probability.
Yes. Yeah. Next time you go, take me with you because I've never done that before.
Okay.
I'd like to know.
But
I'd like
it's
to know
kind of
how it
uncomfortable,
works.
so.
Have you eaten it today?
Not yet.
Okay, go eat, and then if you're going to go donate, go today.
Yeah.
Oh my gosh. I can't believe we sell our bodies to get money. It's just...
Sell our body.
We're selling our life force for money. It's pathetic. No, it's called being broke. The first couple of times they pay you like the first 3 times you can get like 500.
Maybe I have blood. I've never done it.
Well, I can't do it because I only have one artery in each hand. If I screw it up, I like lose a hand. So.
Okay, so Stephanie, I think it would be 0.1745.
Okay, that's what I've got. So that's what I wanted to make sure that we're not doing the middle, because it says under the curve,
Uh-huh.
but it
curve,
also says to the right and the left. So I can't remember how to do that. You see?
Okay. Yeah, I got the same thing.
Okay, so 0.1745.
0.14755?
No, point.
0.17, actually 0.175, right? Because we're rounding it to the,
Oh, yeah.
round your answer to 3 decimal places.
Uh-huh.
You want me to go with you, Paige?
Okay, so down to
Yeah, that way you don't pass out on your way home. Then you'll both pass out. Okay. We'll go when I'm done. Hey, we'll go when I'm done. Oh, okay. What time? Sure, we can leave by like maybe 1:45. Okay. We'll talk about it after I'm done. Okay, sorry about that.
What, honey? All right.
Okay.
Oh my gosh.
What?
Yeah.
Okay. So the mean is 185, right?
No, wait.
The standard deviation is 26.7. Assumes the mean weight of a passenger in commercial boats is 185. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7. The weights of a random sample.
Okay, random sample, that's the new formula.
Okay.
Do we use the sample mean or the mean?
Well, the sample mean becomes your X.
Okay, and the 185 is the mu, right?
Yeah.
Correct.
Okay.
So your X bar is 177.6.
Yeah. Okay. All right.
So are you guys done?
No, sorry, hold on one second.
Okay. Oh my gosh, I don't even get what they're asking for.
See, that's my problem.
Okay, so find the places. Example, if the answer is 0.89, then you would enter in the answer box. I've never even heard the term find the places.
Okay, I got negative 1.920.
Yes.
Okay. Okay. So is that our answer for that one?
Abigail, is that what you got?
Yeah. Negative 1.120.
I got negative 1.920.
Oh, yeah. Sorry, I have crappy handwriting. So, yeah, negative 1.920.
I hope that's what they're...
Yeah, see, okay, let's read this again.
The question didn't make a lot of sense.
Just Standard deviation of the passenger weights of a random sample. Sample mean. Find the probability that a random. Okay, so now we need to take that and enter that into the normal probability applet in order to get our answer, right?
Right. Okay, but what are we looking for? Are we looking for the area then? Find the probability. Yes.
That a random sample of passengers will have a weight that is extreme or more extreme. So we have to go to the right of the probability applet because it is as extreme or more extreme.
Okay, so are we doing under the curve and to the right?
No, it's got to be just, it's got to be.
That's to the right.
Oh my gosh.
Okay, let me read this again. Yes.
But more extreme could be, though, the center of the probability applet and the extreme right, just not the extreme left.
Right, because it says either above or below the mean.
And our z-score is negative 1.920.
Right.
So then my answer would be 0.973.
That's what I got, yes.
Ugh. And you think that's right?
Honestly, I don't know. But that's
what I got. So honestly, I think like each of our guesses is as good as another. Because the question's so vague.
All right. Okay, let's revisit that before we leave.
Okay.
Okay, number 5. But I put 0.973.
Okay, that's what I'll put.
Because it says find the probability, which is the area, correct?
Which is the area, yes. That's
so no matter what, you've got to put that z-score in there.
Yeah.
That a random sample of passengers will have a weight that is as extreme or more. Okay, well, I think that's right. All right, number 5.
Okay, so which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? Well, we won't know.
Which of the following will have a smaller standard deviation?
Well, it'd have to be by individual observations, wouldn't it?
See, here's where it comes into play with that X and the bar X and all that.
Mm-hmm.
That's why I wish they would give us better definitions of what these things mean.
Okay, so the X bar is the set of all possible sample means from the population.
Mm-hmm.
And the X is smaller. But I have no clue if it would be smaller or larger.
Yeah, I know.
I think we should say it can't be determined because we don't know.
All right, give me just a second. Okay, so this is what I'm thinking in my head. If you don't have a sample mean, then you don't use the z-score distribution or the z-score thing that says divided by the standard deviation divided by the square root of the value.
Right.
So if you take the information from question number 4 If you did it just with, okay, so we got minus 1.920. If you did it without using the square root, then your answer would be minus 0.277.
Right.
So one is done with just an individual observation, and one is done with a sample mean.
Right.
So which is smaller, minus 1.9 or minus 0.2? Well, minus
1.9. Right?
Yeah.
Okay. I'm trying to go back through my notes. I know I wrote it down somewhere, because didn't we talk about this last week, how like one of them would be smaller.
I think we did in the homework.
Is that where it was?
How is the standard deviation of the distribution of sample means related to the population standard deviation of no, that's not it. Oh my gosh. Yeah, I don't know. Which of the following will have a smaller standard deviation? The distribution of the individual observations.
Well, wouldn't the bar x have a smaller deviation because we're dividing by the square root? Or is that the one that you said would be smaller?
Well, that's the one that was smaller if you just take, yeah. But now I'm looking at negative numbers going, okay, which do you tell is smaller? Is negative 1.9 smaller, or is negative 0.2 smaller? Which one is smaller?
I don't know.
So let's do something positive. Hold on a second.
It'd be negative 0.2 because negative 1.9 is a full integer and then a part of it. And then
so which is smaller?
It should be negative 0.2.
Hold on just a second. Okay, so I think that when you use a sample mean, your standard deviation is larger.
Okay.
And I took number 4, and I put a positive number in 190 minus 185, and then I divided it. Oh, you know what? I don't know. I don't know
either, and this is what frustrates me, is because we didn't even learn it. I have it nowhere in my notes.
Okay, so let's do number 6. Which of the following results implies that the spread in bar x decreases as the sample size increases?
Whoa, time out. If we haven't learned it, that means the information can't be given.
Okay, but then read number 6.
Which of the following results implies that the spread in X decreases as the sample size increases? However, one of them does specifically talk about sample sizes in the homework. And the only one I ever remember being mentioned is the central limit theorem. It's the only thing I remember being mentioned in the homework.
Yeah, but I don't trust these quizzes for homework stuff either.
Well, yeah, I know. I think I'm going to email the professor and be like, look, we're seriously struggling here. Like, this class needs to have the homework match the quiz. Mm-hmm. It's unfair to give us a homework assignment to learn the material by, and then to quiz us on something that is barely understandable. It's not going to show what we know. So.
Yeah, I guess I would have to say the central limit theorem for number 6 too.
Okay.
Or
okay, tell me again what, okay, I just want to make sure I'm understanding. The X bar means the sample, what is it? Tell me what that is. The sample.
Okay, wait a second, you guys. Okay, look at number 6. It's not. It's got to be the law of large numbers. Listen to the definition of the central limit theorem. Describes what happens to the shape of the distribution of sample means when the sample is large. The law of large numbers describes what happens to the spread of the distribution of sample means when the sample is large. So this is talking about the spread, not the shape.
Right. Right.
Which of the following results implies that the spread in the sample mean decreases as the sample size increases? Oh.
But here, the law of large numbers states that if the sample size is large, then the sample mean will typically be close to the population mean. This happens because of, the standard deviation will get smaller, right? Is that what that's saying? I honestly don't know.
But the central limit theorem talks about the shape, right?
Right.
And this is talking specifically about the spread, which is the law of large numbers.
And I don't think it's the central limit theorem because it says as the sample size increases and becomes large, the distribution of sample means becomes approximately normal. So not smaller, just approximately normal. Right?
Yeah. Oh my gosh. I don't know. What do you think, Abigail?
I don't know.
I think it's the law of large numbers.
I'm going to go with that too. Which of the following will have a smaller standard?
Let's go with that.
And I think number 5 might be the first one.
Yeah.
Unless you think it's determined from the information that it can't be determined.
Okay, let's see if we can plug it into a formula.
Well, that's what I did. That's what I did.
So you were looking for X then?
But I wasn't. See, that's the thing. I wasn't looking for X. I was looking for. I just plugged in. I was looking for the Z-score.
Okay.
So that can't be right, right?
Well, the 9 observations. Would that be your X? It's X9?
No, the 9 would be the N, because that's your sample.
Okay,
right?
yeah.
9 observations, so 9 would be N.
Wait, where are we getting these numbers from?
Question 5.
Well, then we probably can't determine this because we don't have...
Yeah, we don't have all the info.
Okay, so put this cannot be determined.
Yeah,
Yeah.
we don't have a mean, we don't have a sample, like...
Yeah, I don't know.
Yeah,
Okay, so on to 7.
yeah.
This is awful.
It is
I thought I understood this, but I guess not. Okay.
Okay.
150.8 standard deviation.
Okay. So on to number 7?
Yep.
Yeah.
All right. Okay. Alright.
So that would be 160 minus 150.8 divided by 8.8, right?
Yep.
Okay.
So the z-score would be 1.045. Because this is just one observation, right?
Yeah, I think so. That's what I'm trying to read over.
You
Yeah.
may be able to answer the questions above it.
Yeah, I know.
Okay, so this is just one observation, and they want to know that z-score. So I believe it's just 160 minus 150.8 divided by 8.8.
I agree.
1.045.
Okay.
Do you guys agree with that? I mean, you can say no.
Oh no.
Yeah, I'm just doing it real quick just to make sure.
Yeah, please do.
Yes, okay. Yeah, I would agree with that. All right.
Okay, so now we take that z-score and pop it into the normal probability applet.
Yeah.
And they're asking what is that a random selected student will score above 160 on the quantitative portion of the GRE. So then we want to go to the right.
Eso no. Eso la basura y eso allá.
And then the area is 0.1480.
That's what I think. 0.148, right?
Yeah.
Sí, porque fumas.
So let's make sure that that's right if we think about that. So that would basically be 14% score above 160, right?
Yes, and your
That makes
mean
sense?
is 150.8.
Yeah.
So 14% could score, so it would make sense.
It makes sense, yeah.
Let's go into the study a little bit.
Okay, so number 9. A random sample of 5 students was selected to take the GRE. Their scores are, what is the z-score corresponding to the sample mean of these students' scores?
Okay, that's the new formula then, right? It's a sample mean, right?
Yes, that is the new formula, and your sample, your n, is now 5.
Okay.
And your X bar is
Well, isn't it still the one? What was that?
so now we have these 5 scores. Are we supposed to find the average, the mean of those 5 scores to get the sample mean, right?
Yeah.
Which we've never done before, but whatever.
I know. So wouldn't it be? Oh, we have to put it in.
So if you added them all up and divided by 5, I got 160.
Okay. Okay, so then it stays the same, right? Because our mean before, no, our mean was different. Our mean was 150.8, right? Yeah. Okay. All right.
But the previous question was 160.
Yeah.
Okay, or are we supposed to put these numbers in order and take the middle number?
Yeah, that's where I get confused, because that's what I was starting out to do, was putting them in order. But even if we do put them in order, guess what it is?
It's 160.
It's 160. So that's our answer there. All right, so that is our mean.
That's your X bar, your new sample mean.
Oh, that's our X bar?
Yes. So then you do 160 minus 158 divided by 8.8 divided by the square root of 5.
Okay, where are you getting 158? Are you meaning 150.8?
Sorry, yes.
Okay.
I'm sorry, 150.8. Sorry about that.
Oh, that's fine. I just wanted to make sure, because like I say, I'm not 100% on this unit, so I just wanted to...
You can always question me. I hope that you would.
Okay. And our standard deviation is
2.338 is the Z-score.
Okay, now hold on one second, Lori. Sorry. So in the square root, is it going to be the 5?
Yes, because that is how many samples you have. So that's your N number, right?
Okay. Yep. That's what I want to make sure I'm doing it the right way. So, okay.
Yeah. Yeah. And they're asking for just simply the Z-score. They're not asking for the area or the probability.
Okay.
Did you calculate that?
Sorry, I'm working on it still.
Okay.
I'm really slow. I have to make sure I know what I'm doing. Okay, I got 2.338. Yes.
Yep,
okay.
That's what I got.
Okay, so that is the Z-score, right? That's the Z-score. Yes. Okay.
Okay, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
Oh my word.
What is the probability? So we've got that the 5 randomly selected students will have a mean score that is greater than the mean. Okay, so do we just take that Z-score and plug it into the probability applet?
That's the only thing I can think of.
Okay, question.
Which gives you 0.0097.
Yeah, that's what I got. Yes, Abigail?
So can you review the last, can you just go over the last 2 steps for me to make sure I did this right?
Mm-hmm.
Because it's not the answer.
What last 2, what are you looking at?
So, the z-score, we are on number 9, right?
Yes.
Okay.
Well,
Yeah. So you take 160 because that is the average of your 5 samples.
Okay.
And you take 160 minus 150.8, which is the mean that's given in question 7.
Okay.
And you divide that by your standard deviation 8.8 divided by the square root of 5.
Okay. And what's
And
the
that gives you 2.338, correct?
mm-hmm.
Yeah.
Okay. So then they asked, what is the probability? So that's the area from your applet, right?
Mm-hmm.
That 5 randomly selected students will have an average score that is greater than the average achieved. Okay. So I believe it is 0.0097, and we have to do it to 4 decimal points.
And I would think that because that's a really small number, and it would have to be a really small number that would actually happen.
Right. That's what my brain is thinking as well.
Mm-hmm.
So 9 is 2.388.
2.338.
2.33. Okay. Thanks. Got it. Okay.
And then when you plug that z-score into the normal probability applet,
Yeah.
and just use the right to the color the thing to the right of 2.338, it's 0.0097.
Okay. Okay, now I'm caught up because I was like, wait a minute, I feel like I missed something.
Okay.
Because I was getting the right answer, but I was like, I don't understand how I got these. So.
Okay, so number 11.
Okay. Now that I'm on the same track. Okay.
I got to get a clean worksheet here. Okay.
Yeah.
Suppose the mean
sampling distribution
Okay,
of.
so your mean is 3.5. Your standard deviation is 0.7.
And then your sample mean.
And this is left skewed.
Okay.
Okay.
So but our random sample is over 30, so that's good.
Yeah.
Oh, whoa, whoa, whoa. Okay, that means the answer is going to be left skewed because if the parent distribution is left skewed, then the sample distribution will be left skewed.
No.
No.
No?
No, because if it's over 30, it turns it into a
Normal.
normal distribution. Approximately normal.
Mm-hmm.
What is the shape of the sampling distribution of the random variable x, which represents the sample mean? Yeah, so it's approximately normal.
Yeah. I would agree.
I'm not a math genius like you.
Okay, so number 12. What is the mean of the distribution of the sample means for all possible samples of 81 that could be drawn from the parent population? My gosh, I don't even know what it's asking.
So.
It's 3.5.
Yeah.
Yes. Yes, it is. Because they're the same.
Yeah. Parent follow. It's like the kid follows the parent most of the time. Okay.
What is the standard deviation of the sampling distribution of the random variable x bar? The mean of the 81 students who are selected. Would it be 0.7?
That's what I would guess.
Because if the one before that was 3.5,
Wait.
and this information is used to answer problems 11 through 15, so it has to be 0.7. I think.
What is the standard deviation?
But it
of the
says to
sample
answer
distribution?
if with 3 decimal places.
Well, we could always put in 2 zeros.
Yeah.
Well, how else do we know how to find standard deviation?
Yeah, we don't know.
Yeah.
So, okay. Yeah.
I mean, do we know any other way to find it out?
Hold on, I'm going to get my dog
I
to be
don't.
quiet.
What is the probability that the mean GPA for 81 students will be less than 3.3? So then the next one is 3.3 minus 5.
All right. Let's see.
Okay, so the next question, if 13 is right, who knows, is 3.3 minus 3.5 divided by 0.7 divided by the square root of 81, right?
Hold on. All right. What is the probability that the mean less than 3.3? Okay, so the mean. All right, what did you put for the X bar?
So the X bar is 3.3.
Okay, wait a minute. Where did you get 3.3?
Well, we're down
right
on
there.
14.
Okay, yeah, okay. 3.3.
So your X bar is 3.3 minus the mean, 3.5,
Yeah.
divided by 0.7 divided by the square root of 81.
Yes, okay.
So that gave me negative 2.571.
How do you do that so fast?
Okay, one more time.
Okay, 3.3 minus 3.5.
Okay.
And then you divide that by the sum of 0.7 divided by the square root of 81.
Got it.
Is that what you got, Stephanie?
Yep,
Uh-huh.
still doing my math.
Now it's asking for a probability, and it's asking for less than. So then we go to the applet and plug in negative 2.571.
Yep, that's what I got. Okay, and you said, let's see, what's it asking for?
And I get 0.0051.
Negative 2.571. Whoa. Wait. Okay. What? Wait a minute. I did not get that. Did I? Oh, never mind. Okay. What did you get?
Did I do something wrong?
No.
0.0051.
Okay, that's what I got. Yep.
Same.
All right.
And then the next question would be 0.995 because you're just subtracting that from 1.
Okay, let's see. What is it called?
0.49.
0.995.
Okay, so we're subtracting the 0.0051 from 1, right?
Correct. Which
Yeah,
gives
so
you
0.995. Yeah.
But 1.14 is supposed to be a 3 decimal thing.
Oh, yeah. Good catch. So 0.005.
Oh, yeah.
Right?
Yeah. Okay, let's look at those and make sure they make sense. What is the...
Okay, good luck with that.
Well, no, like my husband keeps saying, you need to make sure that your number makes sense because I keep getting things wrong. And so...
Okay, so it says the probability will be less than 3.3.
And that
So-
makes sense.
Yes,
Mhm.
because our z-score was a negative 2.571. So that's
Right.
a pretty big negative z-score.
Right.
Okay, and then it says the exact same terminology, but will be greater than 3.3. So even if you go to your normal probability applet and you plug in the area that's all greater than negative 2.571, you get 0.995. Right?
Yes. Yes. Okay. All right.
Okay,
Yeah.
so I'm a little confused with number 13. What is the standard deviation of the sampling distribution of the random variable? What does that mean?
Let me look at my notes again really quick.
What is the standard deviation of the sampling distribution of the random variable x bar?
I can vaguely remember them talking about a random variable, but I can't remember what was said. I am scared for this test that's coming up next week.
There's a test coming up?
Mm-hmm.
Are you kidding me?
Nope, I am not kidding you.
I'm about to cry.
Mm-hmm. Me too.
Okay, now look, in your homework key, or in your homework,
Mm-hmm.
on question 5, it asks what the standard deviation of the distribution of sample mean scores for all such samples. So now I'm
Okay,
going
in
to
the homework
see
part or in the preparation part?
in the homework part.
Okay.
Okay, so what they did is they took the standard deviation equals the standard deviation divided by the sample number. So I'm wondering if you take 0.7 divided by what's our
Sample?
what's our sample size? 81
81. Mhm.
divided by the square root of 81. And so your standard deviation would be 0.0777777.
Okay, I think that's probably what it is.
Well, did you look at your homework sheet?
Okay, yes, I'm looking at the homework sheet.
Okay, so look at question 5, and it says, what is the standard deviation of the distribution of sample mean scores for all such samples?
Right.
So your sample mean scores is your X bar, right?
Yeah. Uh-huh.
And the way they got that answer is they took their standard deviation of 113 and divided it by the square root of 30, which
How did
is
you figure that out?
your sample score, or your sample number.
Okay.
And so then, because I just kept going, I know we did something with standard deviation, and I couldn't find it, but I just found it.
Yeah. Okay, but how are we supposed to know that if we don't do the homework before we meet our group?
Oh my gosh, I always do the homework before I come.
I didn't get a chance. I usually do, but that's what I'm saying. How would we know that?
Yeah, so I always do the homework, and I always take the homework quiz before I come here too.
Okay.
Well, my
So this
question is, why have the homework due
I
after?
know.
Yeah, because I always do the homework like on Friday, because that way I keep the information fresh.
Yeah. So in the homework, that's how they got that standard deviation. So I really think that we
Need to change that to 0.078.
Yeah, what does it say to round it to 3 decimal places?
Mm-hmm.
But what do you guys think? I mean,
I see how you got that, Lori, but I don't know how you got the information to know how to do that? How did you figure that out?
Well, that's why I went to my homework assignment, and I'm looking at.
But does it tell us how to, I don't even remember learning that. How did you figure out that, or you just figured out?
Sure.
Okay.
And I think it was in, you know what, I think it was in the, not the one where the guy stands in front of the chalkboard, but the tutorials before that.
Right, I watch all that, and I just don't remember, but maybe I just take enough notes.
Okay, what question are we talking about?
Homework assignment question 5. And when I compare it to the key, that was right.
Okay.
So, you know, I'm going to go ahead and put it as 0.078 instead of the 0.700, because I just feel like that's not right. But I
okay,
could
and
be
Lori,
totally wrong.
It's fine. It's fine. Don't worry. I want you to tell me. I'm going to write this down on my notes. So tell me exactly how you did that again.
Okay, so in this homework assignment, it asked for the mean of the distribution sample scores, and that's just the mean that they give you.
Right.
The mean is always what they give you. Or in the case of these here, we had to add them up and find the mean.
Right.
Right? Okay. So the mean is always what they say. And then it said, what is the standard deviation of the distribution of sample mean scores for all such samples?
Okay.
Okay, now wait a minute. Now listen. If you go back up to question, I don't mean to be rude.
No, you're fine.
Go back up to question 5, and it says, which of the following will have a smaller standard deviation if 9 observations are randomly drawn for a population? The distribution of the individual observation or the distribution of the sample means? And if you look at this question on homework 7, question 5, the standard deviation of the individual observation was 113. And then when you found it for the sample mean scores, when you divided it by the square root of the n value, it got smaller. It went from 113 to 20.631.
So the distribution of the sample means would be the smaller one, right? For question 5?
Yes.
Okay.
Yes. Which of the following have a smaller standard deviation? The distribution of the sample means? And here it says, what is the standard deviation of the distribution of sample means?
Yep. Yep, I would agree with that.
So that would be the middle one, right? The distribution of the sample means X bar for number 5.
Yes.
Oh, okay. You guys, I may be completely off base, but...
No, I think you're right, Lori. I think you're right.
Making some sense to me now. Stephanie, I'm trying to remember how I got that.
Okay, that's fine. I'll have my husband go through it with me tonight then. I just want to make sure that I'm understanding what I'm supposed to be doing, because that's, and I'll rewatch those videos.
Okay, and because I'm pretty sure that's where I got it. I actually have a tutor that comes to my house, but he canceled on me, so I was on my own for this one. I mean, and I normally
that's why you are so much smarter than us.
No. I always go through all of the stuff, and then I just highlight all the questions, and I ask this tutor. But I didn't feel like I needed him this week. So I think that came from the tutorials.
Okay. All right.
Okay.
We will look at those.
But this is what I have right here. I don't know if you can even see that. Standard deviation equals the standard deviation divided by
the square
root of n.
Okay.
Okay.
Which, if we're reading that right, would make sense with question 5 as well.
Yes, I agree. Okay.
Okay, now, oh my gosh, okay. So let's just go backwards. I think we've got 14 and 15 right. How do we get number 13? What is the standard deviation? Oh, that's what we just did. So we took 0.7 divided by the square root of 81, right?
Yes.
Okay, is 0.778. Okay, and then what is the mean of the distribution of the sample means? Well, it's always going to be the mean that they give you. And
Yes.
that is 3.5, right?
Yep.
We know because n is greater than or larger than 30 that 81 makes the shape of that sample approximately normal, right?
Right, yes.
Because of the central limit theorem. Okay, and then number 10, or let's go, I know, Abigail, you're running out of time, aren't you?
A little.
Okay, so let's go back up to question 7. Scores on the quantitative portion of the GRE. Is it okay if we just double check these?
Yes. Yeah.
I'd way rather get it right.
So we have, and we're just looking for the normal z-score here, right?
Yeah, I think so.
I know sometimes when you go through all of this stuff, then you answer questions further down, you know?
Right.
And the mean is 150.8 equals divided by the standard deviation. And there's no sample mean, so this is just a basic z-score, right? And we got 1.045.
Yes.
And then what is the probability that a randomly selected student will score above 160? So we put that into the normal applet, right?
Yes.
And we got
0.148.
And we felt that that made sense, right?
Mm-hmm.
Okay, and then we took the sample mean, which is 160 for question 9.
Right.
But this is where we had to divide it by
The 5. No, 5 was our n. So we took the 8.8 standard deviation divided by
the square root. Okay, so I'm just going to do that one more time. So 160 minus 1. Oops. Ah. And that was this, then n is 5, right?
Yes.
Oh my gosh. Okay, I've done something wrong. What did you get for that one?
Okay, I'm just working that one out again too. So hold on one second.
Okay, I've got to start over here. Okay, so then I got the 2.338 again.
Yeah, I got 2.337707431, so rounded to 2.338. Yes, I got that speaking again.
Me too. Okay, and then it says, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So it's anything greater than 2.338, correct?
Yeah, yeah. And then we plugged it into the thing on the right side, right?
Yeah, just the, and we got 0.005, right?
Yes.
Oh, no, wait a second.
No, 0.0097.
Yeah, how do we get that? 2.33.
Did
I
you
do
plug
that
in
wrong?
your Z-score the right way? 2.338?
Oh, yeah, I made a mistake. Thank you. Okay, so 0.0097.
Yep.
And that was the only one that we round to the 4 decimals, right?
Yep, it looks like it.
Abigail,
Probably because it's so small.
it's your job to check those, Abigail.
Yeah. Quick question. What did you guys get for number 8? That's the one I'm looking at.
0.148.
Okay. I'm trusting you
Okay.
guys.
Oh, don't trust me. Oh my gosh.
Yeah.
Oh, trust me. Lori, the last
So-
person we want to trust is me on math.
Okay, so number 6, question number, so we're okay with 7 through 10, right?
Yeah, I think so.
So let me just go over it. 7, 1.045, 8, 0.148, 9, 2.338, and 10.0097.
Yes.
Correct.
Okay. We're good.
Okay, so now back to question 6. Which of the following results implies that the spread in the x-bar decreases as the sample size increases? And the law of large number describes what happens to the spread of the distribution of the sample means when the sample size is large or increases. So I really feel like that's the law of large numbers.
I agree.
Yeah.
But, oh my gosh, it could,
Stop second guessing yourself.
yeah, okay, all right. Just don't, if any of these
Oh,
get
Lori, it's not just on your head. It's all of us.
Okay, so I feel like it's the law of large numbers, and okay. And
I
number
agree.
5, if we even thought that through correctly, the distribution of the sample means x bar is smaller.
Yes.
Uh-huh.
If that's
4 is 0.973,
Yeah.
and 3 is 0.175.
yes. Use
Okay.
the normal probability applet to find the combined area under the standard normal curve that is to the right of z and to the left of z. I'm just going to put it in one more time. 1.358, is that right?
Hold on, I'm going to just put it in too. Okay, hold on. Let's read that again.
Easy.
Use the normal probability to find the combined area under the standard normal curve that is to the right of z-score 1.358 and to the left of the z-score negative 1.358.
Okay. Yes, okay.
So,
Yeah.
right?
So we shaded both sides, right? Right and
Right.
left, right?
It
Okay.
says more than 1.358 and to the left of negative 1.358.
Yeah. Okay, so 0.175 is what I came up with, right?
Yes.
Okay.
So it's
Now the
0.175,
only other one that let's just look at number 4 one more time. See, it seems that the mean weight of a passenger is 180. The previous value was lower, but was raised after track. Standard deviation 26.5. The weights of a minus 48. And the mean was determined to be 170. So the sample mean, or the x bar, is 177.6, correct?
Yeah. Yes.
Find the places. I don't get that. Find the places. Example, if the answer is then you could enter. Note, as as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as are in the positive direction.
So does that mean we plug in the number for both sides?
Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean. Oh.
Okay. Does that number make sense? Does 97% basically make sense?
Okay, so tell me what we did. We did 177.6 minus 185, right?
Yeah, let me look. Yes, 177.6 minus 185. Then we did the 26.7 divided by the 48 square root of 48.
And we got a negative 1.921 or 1.920, right?
Uh-huh.
Okay, and then we went and plugged that in. Okay. All right, so
okay.
read the question one more time now.
Yeah. Okay, Lori, here's what I'm thinking, okay? And I don't know if this is right or not, but this is what I'm thinking. Because it says that it is above and below the mean, do we go ahead and follow what we just did in the other one and plug it into both sides? Does that make sense?
Oh, okay. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme and was observed in the sample.
Because I don't think that 97% of the probability, I don't think it would be 97% probability that the weights are extreme one way or the other. Do you see what I'm saying?
I do. So that number doesn't make sense.
It doesn't make sense. No, but if you plug if you plug our z-score in and you do it on both sides of the, you do the blue on both sides, that makes more sense at 0.0549.
Okay, and they just had us practice that in the question above that.
Yes, yes. That's what I'm thinking. What do you think?
I think you're pretty smart. That's
I'm not smart, believe me. There's been lots of wailing and crying and gnashing of teeth here at my house.
Oh my gosh, I can't tell you. My brain and whole body hurts after this class.
Me too.
So 0.0549.
So I would say it's 0.055, right? Does that make more sense?
Okay, let me read it one more time. Find the probability, so it is an area, that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, that was observed in this sample.
What do you think?
Well,
my gosh, I have no idea. I really don't. Because your sample mean is 177.6 and your mean is 185. Your z-score is minus 1.92. and if your mean is 0, that it really does make more sense to me because I mean, but actually, if we're going from one extreme to the other, really, you know what I mean?
Yeah. I would get...
Or is it, okay, or is it this? Or is it what's in the middle of the two extremes?
Okay, let's look at that.
So is it the middle part of the probability applet in between the two bars?
Okay, then that's a 0.945.
Yes.
So 95%.
I just don't understand the question.
I don't either.
Because it says, find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean.
Yeah, I know.
Either above or below the mean. It's got to be what you said. Because your mean is in the middle, right? 95% of your data, or 68% of your data is in the middle, right?
Right.
That's your mean.
Right.
And so they're saying either above or below the mean. So I think you're right, Stephanie. I think it's the point, what was it, 0.0549?
Yeah, so I rounded to 0.055. But I do not know, but that's what I think it is, just because it says the extreme or more extreme.
All right.
And I don't think our extreme or more extreme would be 95%.
Yeah, yeah. And it says above or below the mean.
Yeah.
So honestly, it would either be 100% to me, or it would be the two extremes. So
right.
I'm going to erase that 0.973 and go with what you said, 0.055.
Okay.
Okay, give me like 3 minutes.
Is that what you're doing? And it says round to the end, third decimal.
Yeah, that's what I'm doing. So I just rounded it to 0.055.
Okay.
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 So
are we good?
I think so. And sorry if it's wrong. I really don't know what I'm talking about, but that's just...
Oh, we got 100!
Ah! Are you serious? Yay! Good job, guys! Woohoo!
Oh my gosh, I am so excited.
Well, see, that was worth going over again then. Woohoo!
Yes.
Yep.
Yes.
Good job, you guys.
Yay!
Oh my gosh, I'm just shocked.
All right, woohoo! And hopefully Susan's watching, so hi Susan if you're watching, yay!
Okay, well, and now what? Now what I do is I go back and I write down in a notebook all of these stupid things.
Me too.
And I also print out my quizzes and my homework quiz, so I.
Okay, how did you print it out? I haven't figured that out.
Okay, so you have to be in Chrome.
Okay.
So make sure you're in Chrome, and then let me click done on here so I save that 100%.
Yeah, no
Okay,
kidding.
so then go to details.
Okay.
And then you go in and select all. Like you copy all of it.
Okay. Because I've been trying to do that and I cannot get it to do it. So perfect.
So then you copy all, and then you go into Word.
Okay, all right. And
you
paste it. Okay, perfect. Yay, because that's what I've been wanting to do is on all of our quizzes and everything so that I can review it and take notes on it and make sure I know what I'm doing. So perfect.
Yeah, and that's what I do. And it just worked here, so hopefully that will work for you. If it doesn't, but I found that if you're in Mozilla Foxfire, you can't always copy and paste the quizzes and homework.
Then that's my problem. So, okay, perfect.
Okay. Now, do I have you guys' phone numbers?
I can give you mine.
Can I get your phone number?
Okay, my home phone is 770-693-1574, and if you want to talk to me, that's the best one because my cell phone doesn't get good coverage. But if you want to text me, I can give you my cell phone too.
Okay.
If you email me, it comes to my phone, so.
Okay.
Yeah. So my cell phone is 678-478-4217.
Okay. So, oh my gosh, thanks you guys. We did great.
Yay! We figured it out.
All right. Have a good weekend. Or
You
no,
too.
I guess we'll
Thanks,
see you.
guys.
What's today? Oh, it's Thursday. Yeah, have a good weekend.
Okay.
See you
All right.
Tuesday.
Bye-bye.
Bye.